This is PMS Math channel. Discuss the following relations for reflexivity, symmetricity, and transitivity. First one, the relations are defined on the set of all positive integers by m or n if m divides n. Second one, let P denote the set of all straight lines in a plane. The relations are defined by L or M if L is perpendicular to M. Third one, let A be the set consisting of all the members of a family. The relations are defined by A or B if A is not a sister of B. Fourth one, let A be the set consisting of all the female members of a family. The relations are defined by A or B if A is not a sister of B. Fifth one, on the set of natural numbers, the relations are defined by x or y if x plus 2y is equal to 1. Solution. First one. In first question, a set is given. That set is nothing but the set of all positive integers, means natural numbers, is equal to 1, 2, 3, etc. Then relation is given. Here relation R is equal to M or N is given. M or N means M comma N. Therefore, we can write set M comma N. Here M comma N belongs to N. N means set of all natural numbers or positive integers. And another condition is given. M divides N. Consider M comma M. Here M belongs to N. First number belongs to N. This N, this set. Second number belongs to this set. Same set. Here first number divides second number is given. Here first number and second number are equal. That means first number divides second number. M divides M. Therefore this condition is satisfied. M divides N. Hence M comma M belongs to R. For all M belongs to N. A comma A belongs to R. For all A belongs to S. S means general set. This is general relation set. Here this R is a given relation set. This is the condition for reflexive relation. This condition is satisfied here. Therefore we can say given set the relation R is reflexive. Then consider M comma N belongs to R. Here M comma N belongs to N. That means both numbers are natural numbers. Here M comma N belongs to R means M divides N. When M divides N, then N does not divide M. Here first number divides second number, but second number does not divide first number if M is not equal to N. Then we can write hence M comma N belongs to R. Here M comma N belongs to R, but N comma M does not belong to R. That means A comma B generally we can say A comma general condition. Therefore here we can write belongs to R. Okay, gives B comma A does not belong to R. Oh, here does not belong to R. That means this condition is not satisfied. The relation R is not symmetric. Then consider two elements from given relation R. First one M comma N and N comma L belongs to R. Here M, N, L belongs to N. That means three numbers are natural numbers. When M divides N and N divides L, since here first element belongs to R and the second element also belongs to R. That means this first number divides second number. Here first number divides second number. Therefore we can say When m divides n and n, this n divides L, this L, then we can say m divides L. Reason is, for example, here take 5, here 10, here again 10, here both are same, therefore 10, here take 20. Then 5 divides 10 and 10 divides 20. Then we can say 5 divides 20. Then here, this is 5. 5 divides this 20. Here 20 is L. L is 20. Therefore, we can write hence first number comma second number m comma n belongs to R since m divides n. Therefore, m comma n and here first number divides second number. That means n comma L belongs to R. Gives here first number m, second number L. First number divides L. Therefore, m comma L belongs to R. That means generally we can say a comma b and b comma c belongs to R gives a comma c. Here b equal. Therefore, we can take first number and last number. This is a comma c. That a comma c belongs to R. 4. This is the condition for transitive relation. Here these two numbers are equal. Therefore, we can take first number and last number. That means m comma l. That m comma l belongs to R. That means this condition is satisfied. Therefore, we can say the relation R is transitive. Then second one. In second question, relation is given L or M. That means L comma M. L comma M. Those L comma M belongs to P. Here P is set of all straight lines. Consider L comma L. Here this L belongs to P. P means set of all straight lines. Then take our condition. What's the condition? Here condition is given. First straight line is perpendicular to second straight line. The straight line L, this L is not perpendicular to this straight line L. The reason is a straight line is not perpendicular to the same straight line. Therefore, here we can write hence L comma L does not belong to R. For all L belongs to P. Generally, we can say A comma A does not belong to R. For all A belongs to S. Here S is general set. 4. A comma A belongs to R. For all A belongs to S is the condition for reflexive. But here A comma A does not belong to R. L comma L does not belong to R. The condition for reflexive relation is not satisfied. Therefore, we can write the relation R is not reflexive. Then consider L comma M belongs to R. Here L comma M belongs to P. P is set of all straight lines in a plane. If the straight line L is this L, this straight line L is perpendicular to the straight line M, then we can say the straight line M is perpendicular to the straight line L. If a straight line is perpendicular to another straight line, then that second straight line is also perpendicular to first straight line. Therefore, we can say if the straight line L is perpendicular to the straight line M, then straight line M is perpendicular to the straight line L. Now, we can write hence L comma M belongs to R gives M comma L belongs to R. That means here L comma M belongs to R. M is perpendicular to L. That means M comma L belongs to R. Generally, A comma B belongs to R gives B comma A belongs to R. 4. This is the condition for symmetric relation. This condition is satisfied here. Therefore, we can write the relation R is symmetric. Then consider L comma M belongs to R and M comma N belongs to R. L, M, N belongs to P. P is set of all straight lines. L comma M belongs to R means L is perpendicular to M. Here m comma n belongs to R means m is perpendicular to n. Therefore, we can write when the straight line L is perpendicular to this m and this m is, the straight line m is perpendicular to this straight line n, this n. Then we can write this L is not perpendicular to n. A straight line is perpendicular to second straight line, then second straight line perpendicular to third straight line. From this statement, we can say first straight line is not perpendicular to third straight line. That means L is not perpendicular to n. In this case, we can write hence L comma m, L comma this m, and the m comma this n, belongs to R. Since L is perpendicular to m and the m is perpendicular to n. Therefore, here we can write L comma m and m comma n belongs to R, but gives L is not perpendicular to n. That means L comma n does not belong to R. Here not means does not belong to R. This element does not belong to R. That means A comma B and B comma C belongs to R, gives A comma C does not belong to R. Condition for transitive relation is nothing but A comma B and B comma C belongs to R, gives A comma C belongs to R. But here does not belong to R. Therefore, this condition is not satisfied. Therefore, we can write the relation R is not transitive. Then third one, relation is given. Here the relation R is equal to A or B is equal to A comma B. Here A comma B belongs to A. Here A is nothing but set of all members in a family. Consider A comma A. A is a member. This A is the same member. Both are equal here. A comma A. Therefore, we can write A is not a sister of A. This condition is given. Here, first member is not a sister of second member. That means A is not a sister of B. Is given. Generally, it is given in our question. We know that a person is not a sister of same person. Generally, we can say A is not a sister of A. Therefore, we can say A comma A belongs to R. For all A belongs to A. Right, A comma A belongs to R. For all A belongs to S. S is general set. Oh, this is the condition for reflexive relation. Here, this condition is satisfied. Therefore, the relation R is reflexive. Then, consider A comma B belongs to R. That means A is not a sister of B. A comma B belongs to A. If A is not a, here, A is not a sister of B, B is a sister of A, or B is not a sister of A. If A is a male member, then we can say A is not a sister of B. If B is a female member, therefore male is not a sister of female. Male is not a sister of female. But that female is a sister of male, maybe. If A and B are females, then we can say here A is not a sister of B. Therefore, B is not a sister of A. B is not a sister of A. Therefore, here second element, actually B comma A does not belong to R. Then take the general condition for symmetric relation. What's the condition for symmetric relation? A comma B belongs to R, gives B comma A belongs to R. But here does not belong to R. That means this condition for symmetric relation is not satisfied. Therefore, the relation R is not symmetric. Then consider A comma B and B comma C belongs to R. Here A, B and C belong to A. A is set of all members in a family. Here from this A comma B we can write if A is not a sister of B, and from this element we can write B is not a sister of C, then A is not a sister of C, or A is a sister of C. Both cases are there. Therefore in this case we can write this first one, A comma B belongs to R. B comma C also belongs to R. But third element, A comma C does not belong to R. General condition. A comma B and B comma C belongs to R gives A comma C belongs to R. Is the condition for transitive relation. But here does not belong to R. Therefore, this condition is not satisfied. Therefore, the relation R is not transitive. Then fourth one. Relation is given. Here the relation R is given is equal to A or B. A comma B, then A comma B belongs to A. Here A is nothing but set of all female members in a family. Consider A comma A. A belongs to A. A is set of all female members in a family. A is not a sister of A. A person is not a sister of the same person. Hence, A comma A belongs to R. Here we can write A comma A belongs to R. This condition is given in our question. First one is not a sister of second one. That condition is satisfied here. Therefore, we can write A comma A belongs to R. For all A belongs to A. A is set of all female members in a family. A comma A belongs to R. For all A belongs to S. S is general set. This is the condition for reflexive relation. This condition is satisfied. Therefore, we can write the relation R is reflexive. Then consider here A comma B belongs to R means A is not a sister of B. If A is not a sister of B, then B is not a sister of A. Since here A and B are females. A is not a sister of B, then surely we can say B is not a sister of A. Hence, A comma B belongs to R gives B comma A belongs to R. Then take general condition for symmetric relation. A comma B belongs to R gives B comma A belongs to R. 4. This condition is satisfied. Therefore, the relation R is symmetric. Then consider A comma B and B comma C belongs to R. A, B, C belongs to A. A is set of all female members in a family. That means A, B, C are females. If A is not a sister of B, we can write since belongs to R is there, and B is not a sister of C, we can write since belongs to R is there. From this statement we can write then A is not a sister of C, or A is a sister of C. Both cases are there here also. Hence, A comma B and B comma C belongs to R gives A comma C does not belong to R. Take general condition for transitive relation. A comma B and B comma C belongs to R gives A comma C belongs to R. This is a condition for transitive relation. Here does not belong to is there. Here also does not belong to. Therefore, that means this condition is not satisfied. Therefore, the relation R is not transitive. Then fifth one, set is given. The set of all natural numbers is given, that means n. Set 1, 2, 3, 4, etc. Then relation is also given. Here the relation R is equal to x or y is equal to x comma y. Here x comma y belongs to n. That means x and y are natural numbers. An equation is given. X plus 2y is equal to 1 is also given. From this condition, we can write the set R. Relation set can be written null set. Since x plus 2y is not equal to 1 when x comma y belongs to n. This equation is not satisfied when x and y are natural numbers. Therefore, we cannot write the elements in this set. That means null set. Then consider this x comma x. X belongs to n. In this null set, there is no element. Therefore, this element does not belong to R. Hence, x comma x does not belong to R for all x belongs to n. Take general condition for reflexive relation. A comma A belongs to R. But here does not belong to is there. Therefore, here also does not belong to. For all x belongs to S. S is general set. The condition for reflexive relation is not satisfied. Therefore, the relation R is not reflexive. Then consider x comma, here there is no number. That means this is null element. This null element belongs to R. Here R is null set. Here null element belongs to null set. This is also null element. Null element belongs to R. Then take general condition. A comma B belongs to R gives B comma A belongs to R. 4. This is a condition for symmetric relation. This condition is satisfied. Therefore, the relation R is symmetric. Then consider null element belongs to null set. Again, null element belongs to null set. Here, this null element belongs to R. This null element belongs to this null set R gives here second number and first number are equal. Here B equal. Then we can take first number and the last number. A comma C belongs to R. This is the condition for transitive relation. Here B equal. Here Y equal. Therefore, we can take this number and this number here. This null element belongs to null set. This condition is satisfied here. Therefore, we can write the relation R is transitive. Then note, an empty relation can be considered as symmetric and transitive.